In this video, we are going to continue looking at some of the questions from the optimization quiz, starting with question 3. Question 3 says, find the absolute maximum and absolute minimum values of the function f of x equals x cubed minus 5x to the 15x squared plus 72 plus x plus 7 on the interval from -1 to 7. So they're limiting our interval, which means that the maximum value could occur at the end point of the interval. So what we need to do is take the derivative, find the critical points, and then test the critical points and the endpoints to see if they provide us with an absolute maximum or an absolute minimum. So let's do that now. Let's share that screen. So here's the question. So once again, we need to take the derivative of this polynomial and set it equal to 0. So the derivative would, using the power rule, we would get 3x squared minus 30x, and then plus 72, and the 7 would become 0. Setting that equal to 0 looks like this. We recognize that the 3, the 30, and the 72 are all divisible by 3, so we factor that out. And then once again, we factor the trinomial and get x equals 4 and x equals 6 by setting each of these little binomials equal to 0. Now we test the y values and the endpoints on the interval. So we test the y values at the endpoints on the interval and the critical points on the interval. So our two critical points here are x equals 4 and x equals 6. So we plug those into our original function along with the endpoints, which were a -1 and 7. So here, if you plug them into the original function to get the y values, you get at -1, the furthest left, you're at a -81. When x is 4, you're at 119. When x is 6, you're at 115. And when x is 7, you're at 119. So our absolute minimum on the interval is a -1, 81. And our absolute maximum on the interval is 119. So let's put that in here. The absolute maximum was 119, and the absolute minimum was a -81. Now we go on to question 4, which says, use the given graph of the function f to answer the following questions. So here our x values are each box and our y values too. Enter the open intervals in interval notation on which f is concave upward and separate multiple intervals by commas. So concave upward is when it could catch rain, right? So it looks here. Now we have concave downward in this area and concave upward here. So I'm thinking concave upward is occurring starting here at when x is 2 and then goes to x is 4. And open interval means we use parentheses. And then it looks also here like we're concave upward from 4 to 5. So we separated that with a comma. So these are not ordered pairs. These are the intervals from x is here 2 to x is 4. We're concave up. Those are intervals. And we want to do the same thing on B for where it's concave down. So looking at this, starting from 0 and going to 2, we're concave down. Then it also looks concave down here, starting at this point right here and going onward to 8. So this has an x coordinate of 5. So from where x is 5 to where x is 8, we have a concave down shape. And then enter the ordered pairs for the points of inflection. So points of inflection are defined as where the curve changes from concave upward to concave downward, or vice versa. So going back to our graph here, looks like we are changing from concave downward to concave upward. And this is, we can only guess at this point because we don't have the exact equation to solve for the critical points. But looking at the graph, they tried to make it pretty simple for us. So on this one, looks like you're changing from concave down to concave up at the point 2, -5. And then also, okay, here we're concave up and here we're concave up. So even though this is a critical point, because we have a cusp here, it's concave up on the left and concave up on the right. So it's not considered an inflection point because the concavity needs to change. So where we do have another inflection point is here at 5, -5. We're changing from concave up to concave down. So we'll like that. All right, I hope that was helpful. Please email me with more questions or come to the Zoom office hours on Tuesday. Thanks.